in this lesson, I'm going to add a few more terms and look how we can verify some properties with analytic geometry. This is the last lesson in the unit, and then we'll go into review and do a test after this. So just 2 examples today, really. We have a rectangle. It's defined by these 4 vertices. So we want to show that the diagonals are of equal length and bisect each other. So let's start with a little diagram here. So 10, 2, change my scale here a little bit. 10, 2 would be over here. Negative 8 and 8 we'll put up here. Negative 12 and negative 4 will be down here. And D, 6, negative 10 will be down here. So that should be roughly a rectangle. And I just estimated these points, but roughly a rectangle. Okay, we're asked to figure out or show that the diagonals are of equal length. So the first thing you have to ask yourself is, what is a diagonal? Well, diagonals go from corner to corner across the middle of the shape. So we have 2 diagonals, and another fancy word here, a line join non-consecutive vertices. Okay. But our vertices are not in alphabetical order, sorry, our lines are not in alphabetical order anymore. If I want to show they're of equal length, I need to use distance. But I need to figure out the distance from A to C and the distance from B to D. If I can do that and find they're the same length, well, then the diagonals are equal length. So let's give it a try. So A to C. Oh, no, sorry, not A to C. We're not using A's and C's. We gotta fix that. J to L and K to M. I used the wrong letters here. Sorry, I'll fix that. This is J, K, L, and M. Okay, so let's try J to L. X2 minus X1, negative 12 minus 10 squared, plus Y2 minus Y1. Okay, we're going to figure out the brackets inside first. So negative 22 squared plus negative 6 squared gives me the square root of 484 plus 36. In other words, 520. I don't care what the decimal is. I just want to be able to compare. I want to show they're the same. So let's do the same thing with Km. So x2, 6 minus negative 8, plus y2, negative 10 minus 8. Do our brackets first. We're doing bed mass here. We'll get 14 squared and negative 18 squared. And if I square them, 196 plus 324, hey, it comes up to 520. So I've shown that my diagonals are equal length. Root 520 is the same as root 520. Now that was the first part of the question. The second part of the question said, and bisect each other. So that's a new word for us, bisect. Bisect means cut in half. Cut in half. Well, if I cut a line in half, what point am I going through? Wouldn't that be a midpoint? If I cut the other one in half, wouldn't it be the same midpoint? So if I can find the midpoint of JL, and I can find the midpoint of KM, what should be true about them? They better have the same coordinates if they cut each other in half, right? So this is a chance to practice our midpoint equation. I'm just going to make this a little bit smaller here so I can fit it on the same page. All right, so we're going to find the midpoint of JL. Now J, we're going to do x1 plus x2 this time, divided by 2, and y1 plus y2 divided by 2. What's that come out to? Negative 2 over 2 is negative 1, and negative 2 over 2 is negative 1. When I do the next midpoint, we're going to do k to m. Hopefully get the same answer. Let's give it a try. Negative 8 plus 6 over 2, and 8 plus negative 10 over 2. What's that going to give us? It's going to give us negative 2 over 2, which is negative 1, and negative 2 over 2, which is negative 1. Hey, those are the same midpoints. So I've proven everything I need to. These diagonals are the same length, equal distance, and they cut each other in half. They have the same midpoint. That's all I was asked to figure out. So it's really just practicing our formulas here. As I said, we only have 2 questions today, so here's the second one. Unfortunately, this one's a little bit longer. So, verify that the midsegments of the quadrilateral ABCD form a rhombus. So another new word, our third word today. Midsegment. What is a midsegment? A midsegment is a line that joins consecutive midpoints together. So I need to take my graph, A, B, C, and D, and I need to graph it. So let's give it a try. This is what it should look like. Now, I don't want to verify that this shape is a rhombus, and look at the picture, it's definitely not a rhombus. I want to find the midsegments and show that they form a rhombus. But midsegments join consecutive midpoints. So stage 1 of this problem is we actually have to figure out what the midpoints of each of these sides are. I need to figure out the midpoint of AB. Let's give that a try. Midpoint of AB. We're going to have 0 plus 2 over 2 and 0 plus 6 over 2, which is going to give us 1 and 3. And then I got to do the next midpoint, B and C. So I got to do 2 plus 8 over 2 and 6 plus 5 over 2. That's going to give us 5 and 5.5. That would be this one, right? And I go to the next one, C and D. So 8 plus 10 over 2 and 5 plus 1 over 2. That's going to give us 9 and 3. 9 and 3. Oh, perfect. And then I go back to the beginning, A to D, and 0 plus 10 over 2, and 0 plus 1 over 2. And we're going to get 5 and 0.5. 5 and 0.5 right there. And now I need to figure out the midsegments. That's the lines that join each of those together. And prove those 4 lines form a rhombus. So I'm going to start ignoring the points I started with and now use my 4 new points. To make my life easier, I'm going to label them, okay? I'm going to call this W, X, Y, and Z. Because I don't really need the A, B, and C anymore. I just need the new letters. What do I need to do to prove something's a rhombus? I need to know 4 slopes, and so there's no perpendiculars, and 4 distances, and so they're all the same. That's the proof of a rhombus. So I need 4 more pieces of information now. Let's try doing our slopes first. Okay, so I need, and this just so I can see them, I wrote them down here, okay? Same points, so it's easier for me to see. I need the slope from W to X. Oops, not S. Try again. M from W to X. So Y2 minus Y1, X2 minus X1 gives me 2.5 over 4. Can't simplify it. But let's find my distance. W to X. The square root of 4 squared plus 2.5 squared comes out to 22.25. Do the next one. X to Y. So we put them in alphabetical order, right? 3 minus 5.5 and 9 minus 5 gives negative 2.5 over 4. Huh. Well, those aren't perpendicular because even though they have opposite signs, they're not reciprocals. So I'm on the right track to proving that this is a rhombus. No perpendiculars. And I've actually seen these numbers before, right? 4 squared plus negative 2.5 squared is 22.25. That's also on the right track because they have to all be the same length. Let's try the next one. The slope of Y to Z. Okay, Y to Z, 0.5 minus 3 and 5 minus 9 is negative 2.5 over -4, and we know that two negatives make a positive. Now, I've seen these exact numbers right here, so I'm not even going to show the calculation. I'm just going to write down that YZ is the square root of 22.25. You don't have to show it if you know it, and you do know it because you've seen those numbers. If they were different numbers, you'd show it. Okay, last piece. We need the slope from the beginning, which is W, to Z, just to make sure we do it right here. So we got 3 minus 0.5, or 0.5 minus 3. And on the bottom, we're going to have 5 minus 1. That gives me negative 2.5 over 4. Okay, I've seen those numbers before. They're right here. So I know the distance from W to Z is the root of 22.25. Same answer we had here. Have I proven this is a rhombus? Do I have 4 equal lengths? I sure do. They're all 22.25s. Have I proven I have no right angles? I have. I have no negative reciprocals. Therefore, it's a rhombus, which is exactly what we're asked to prove. But we're asked to prove using the mid-segments, not just the original shape. So that's a long one. Ain't nothing complicated there. It's easy to mess up a sign, and one small calculation, you add or subtract something wrong, will throw everything off. So you have to be careful, but it's not actually overly difficult. Okay, no questions to try. We got 4 today, and just practice using our equations. And then that's the end of the unit, as I said, and we'll do a review and a test next.